10. So the eigenvector, right, so 20 minus 20, 10, so 10 will be common, so you will get x1 upon 2, x2 upon minus 2, x3 upon 1. So the eigenvector corresponding to lambda is equal to 15 is 2 minus 2, 1. Okay, so thus the eigenvalues of the eigenmatrix A is equal to lambda 1 is equal to 0. Okay, and lambda 2 is equal to 3 and lambda 3 is equal to 15, and the corresponding eigenvectors are 1, 2, 2. This is eigenvector corresponding to lambda is equal to 0. 2, 1 minus 2, this is eigenvector corresponding to lambda is equal to 3, and this is eigenvector corresponding to lambda is equal to 15. So 2 minus 2, 1. Okay, so here the complete solution of this question. Next question, question 6b. Find the matrix that diagonalizes A and determine P inverse AP, where A is equal to this is again 3 cross 3 matrix, 2 0 minus 2 0 3 0 0 0 3, right? And this question was asked in 5 marks. Again we have to solve this question with the same method. We have to find the eigenvalues, corresponding to eigenvalues we have to find the eigenvectors, and that eigenvectors we have to write down as a column. So that matrix is our P, right? So and then we have to find P inverse AP. Okay, so just similar method to the previous example. Here is the solution, the characteristic equation. First of all, we have to find the characteristic equation to find out the eigenvalues. So here is the characteristic equation of A is given by determinant of A minus lambda I, that is equal to 0. So in the main diagonal entries we have to just add minus lambda and find out that determinant. 2 minus lambda, 3 minus lambda, 3 minus lambda, other elements are same, right? So 2 minus lambda into 3 minus lambda square, because other elements are 0, you can see. So when we find out the, right, 2 minus lambda into 3 minus lambda square, that is equal to 0. So the values of eigenvalues are 2, 3, 3. In other words, you can also find out the eigenvalues directly, because you can see this is the upper triangular matrix. In the main diagonal entries, right, in the main diagonal entries, below that main diagonal entries all the elements are 0 here. So you can see, you can say that this is upper triangular matrix, and in upper triangular matrix or lower triangular matrix, the main diagonal entries are exactly the eigenvalues. So similar method, you can see the 2, 3, 3, and what is our main diagonal entries? 2, 3, 3. So that 2, 3, 3 are exactly the eigenvalues. Now corresponding to this eigenvalues, we have to find the eigenvector. So the eigenvector x is equal to x1, x2, x3, corresponding to the eigenvalue lambda is given by the matrix A minus lambda I into x is equal to 0. So 2 minus lambda 0 minus 2, we are writing the same matrix into x1, x2, x3, that is equal to 0, 0. Put lambda is equal to 2, so you will get 0, 0 minus 2, 0, 3, 0, 1, 0 and 0, 0, 1. Okay, now we have to convert this matrix into a row echelon form, right? But directly you can also solve this matrix. You can see minus 2 x3 is equal to 0, so x3 is 0, then x2 is equal to 0, 1 into x2, that is equal to 0, so x2 is 0 and then x3 is 0. So x1 is only one free variable, otherwise x2 is 0 and x3 both are 0. So x1 is free variable, so take x1 is equal to k, and that's why you will get eigenvector corresponding to lambda is equal to 2 is 1, 0, 0. So the eigenvector corresponding to lambda is equal to 2 is 1, 0, 0. Now also we want to find the eigenvector corresponding to lambda is equal to 3. So put lambda is equal to 3 in these equations. You can see, put lambda is equal to 3 in these equations, you will get minus 1 0 minus 2, right? This is 0 0 0 and this is also 0 0 0, so you will get only one equations, minus 1 0 minus 2. So minus x1 minus 2 x3 is equal to 0, right? X2 is a free variable. You can see x2 is a free variable, and and you can see in this matrix, this is row echelon form matrix. In this matrix, in the second column and the third column, we don't have any leading entry, so that's why the second column is for x2, so third column is for x3. So take x3, x2 is already free variable, take x2 is equal to k and x3 is equal to t. Okay, so x2 is equal to k. So one eigen vector is you will get 0 1 0, correct? And when you take x3 is equal to t, you will get x1 is equal to minus 2t, correct, from these equations. So that's why you will get the eigen vector corresponding to lambda is equal to 3, that is one eigen value. I already told you that 0 1 0, and another eigen vector is we take x3 is equal to t, so x1 is equal to minus 2t, so you will get minus 2 0 1, okay, minus 2 0 1 and 0 1 0. These two are eigenvector corresponding to lambda is equal to 3. So minus 2 0 1 and 0 1 0. Now taking all eigenvectors as columns, we form the matrix P. What is our matrix P? The first column, you can see the first column is exactly the eigenvector corresponding to lambda is equal to 2. Okay, corresponding to lambda is equal to 2, right? 1 0 0, you can see this is 1 0 0 is eigenvector corresponding to lambda is equal to 2, right? So that is exactly our first column, and then corresponding to lambda is equal to 3, we get two eigenvectors, that is minus 2 0 1 0 1 0. So minus 2 0 1 0 1 0. So this our new matrix P, how we define, as all the columns are exactly the eigenvectors corresponding to each eigen values. Now also we want to find P inverse AP. So basically we have to find the inverse of this matrix, right? Then P inverse AP, so multiplication of three matrices, and then we have to find. But directly also you can write P inverse AP, because of P inverse AP is a diagonal matrix. That means what? Only the main principal diagonal, except the main principal diagonal elements, all the elements are 0. And what are the elements in the main principal diagonal? Exactly the eigenvalues. The P inverse AP is nothing but the diagonal matrix, and in the main diagonal entries are exactly the eigenvalues, that is lambda 1, lambda 2, lambda 3. Now what is lambda 1? This eigenvector is corresponding to lambda is equal to 2, right? So that is lambda 1. Now the second and third eigenvectors are corresponding to lambda 2 and lambda 3, which is 3. So that's why this is 3 3. So 2 3 3, other elements are same, other elements are 0, other elements are 0. If you want to check, just check this P inverse AP is correct or not, right? At your home you have already P, this is our P, right? A is already given in the statement of the example, right? You can also find the inverse of any matrix. That you should know that how to find the inverse of any matrix, any 3 cross 3 matrix. You have lots of methods, adjoint method, using adjoint method, using row echelon method, you can find, right? So find the inverse of this matrix P, and then multiplication, matrix multiplication, that you should know. So just check P inverse AP is correct or not. Okay, I write down here directly, but you have to check it. Okay, so next question, question 6C. Reduce the quadratic form 2x1 square plus 2x2 square plus 2x3 square plus 2x1 x3 into canonical form, right? Here is the matrix associated with the given quadratic form is 2 0 1. Okay, what is the coefficients of x1 square, x2 square, x3 square? That is the main diagonal elements, right? Now what is the coefficient of x1 x2? There is no term in the x1 x2, so that means what? 0. So 0 0. What is the coefficient of x1 x3? That is 2 divided by 2, so this is 1 1. And then coefficient of x2 x3, that is also 0, so that's why here 0 0. So this matrix is nothing but from these equations you can write, right? Now with the same method, again this example is similar type of example. Again we have to find the eigenvalue, and corresponding to each eigenvalue we have to find eigenvectors. So here is the characteristic equation of A is given by determinant of A minus lambda is equal to 0, 2 minus lambda 0 1, 0 2 minus lambda 0 1 0, 2 minus lambda, that is equal to 0. Solve this determinant, 2 minus lambda cube, right? 2 minus lambda cube minus 2 minus lambda, that is equal to 0. 2 minus lambda will be common from these two terms, so you will get 2 minus lambda square minus 1, that is equal to 0. In that is nothing but lambda square minus 4 lambda plus 3, right? Plus 4 minus 1, that is plus 3 is equal to 0. So you will get 2 minus lambda, lambda minus 1, lambda minus 3 is equal to 0. So the eigenvalues are 1, 2 and 3. Now corresponding to 1, 2 and 3 we have to find the eigenvector, right? So the eigenvector x is equal to x1, x2, x3 corresponding to an eigenvalue is given by determinant of A minus lambda x is equal to 0. So with the same method, right? 2 minus lambda 0 1, 0 2 minus lambda 0, 1 0 2 minus lambda x1 x2 x3, that is equal to 0 0 0. Now this gives these equations, these three equations you can see, right? And put lambda is equal to 1 in these three equations, you will get this equation, x1 plus x3 is equal to 0, x2 is 0, x1 plus x3 is 0, so x1 is equal to minus x3 and x2 is equal to 0. So taking x3 is equal to minus 1, we get x1 is equal to 1. Similarly, as the eigenvector corresponding to lambda is equal to 1 is 1 0 minus 1. Similarly, we can find the eigenvector corresponding to lambda is equal to 2 and lambda is equal to 3. That is 0 1 0. Easily you can find, right? We already solved this type of two examples. We already solved similar type of examples. This is eigenvector corresponding to lambda is equal to 2, and this is eigenvector corresponding to lambda is equal to 3. So x1 x2 x3 are orthogonal vectors. Taking x1 x2 x3 as columns vectors, we form matrix P as P, right? This all the columns are eigenvectors. Now substituting x is equal to py, that eliminates cross product term is given by x1 x2 x3, that is equal to this matrix into y1 y2 y3. So x1 is equal to y1 plus y3, x2 is equal to y2 and x3 is equal to y3 minus y1. Now the given quadratic form becomes 2x1 square plus 2x2 square plus 2x3 square plus 2x1 x3, right? Put the value of x1 x2 x3 in these equations, right? 2 will be common, and put the value of x1 x2 x3 in these equations and just simplify. So finally you will get 2y1 square plus 2y2 square plus 6y3 square, which is in canonical form. Okay, so here is the complete the solution of this question up to question number 6. Question number 7 is left. So